lah that time. Tempat yang saya ada kat situ rasa dalam 6 kot. 6 ke 7 macam tu lah. Yang main dia tu dekat Sendai tu lah. Itu memang teruk lah. Sebab dia ada tambah dengan tsunami lagi. So memang, tapi dia tak, dia once in a blue moon lah jadi benda macam tu. Hari biasa tu dia ada sikit-sikit shaking macam tu. Itu tak ada apa. Awak boleh sambung tidur je.
Sir, kat sana Jepun salji lah sir, setiap masa? Jepun kat sana salji tak?
Salji ada salji. Tapi salji ni dia cantik. Tapi awak kena tahan sikit lah sebab dia sejuk sangat lah. Tak boleh tahan lah.
Kalau winter tu berapa degree tak?
Winter tu depends lah. Kalau awak dekat Hokkaido, yang pulau yang kat atas tu kan, dia winter tu around I think -10, -20 can go lah. Kalau you kat bawah Pulau Honshu, Bali pagi pun -5 macam tu lah, -5 tu boleh kira sejuk sangat lah.
Minus tu sejuk sangat.
Tapi
kita malam 20 something pun dah tak tahan kan.
Tu sir, kecil saya pun tak minus.
Apa?
Saya punya pita ais pun tak minus.
Ya, dalam TS lagi panas.
Tu apa panas.
Tapi you ada ni lah, heater lah. Kalau you pergi sampai waktu winter tu, tak perlu pergi TS lagi lah.
Sir, saya nak tanya satu soalan sir.
Ya, apa?
Sana perempuan cantik lah sir?
Ya Robby,
You tengok sendiri lah. Ada nak kenal kan?
Soalan valid ni. Tak tahu
soalan
juga.
valid sir. Kita orang nak tahu sir macam mana.
Dulu saya pernah kerja part time tau. Part time saya ajar bahasa Melayu.
Ada crush tak sir?
Saya ajar bahasa Melayu. So saya ajar kat budak universiti lah, budak Jepun yang boleh cakap bahasa Melayu. Adalah. Tapi dia muda sangat lah.
Oh, dia muda.
Kalau dengan korang maybe padan lah.
Tapi diorang semua baik-baik lah sir?
Tengok lah.
Ada yang pakai tudung tak sir? Ada orang Jepun pakai tudung tak?
Ada. Itu cerita lain lah. Kita kena buat tutorial dulu sekarang. Sekejap. Apa ni? Kena resubmit. Saya jawab dulu lah. Can allow me resubmit? Yes. The window will be open. Macam mana saya nak jawab? Saya jawab dalam grup ke? Ramai sangat tu.
Jawab dalam grup sir. Semua orang boleh baca.
Resubmission. The window will be open for resubmission if you can finish
Sir, kat Jepun ada lauk-lauk ke sir? Macam ayam masak merah ke?
tak ada. Masak sendirilah.
Nasi goreng ada tak sir? Nasi goreng?
Ada kedai tapi jauh sikit lah. Do I just change the email? So change email.
Kat sana sir apa sir? Petang-petang ke?
Ya.
Kat sana sir main sukan ke? Macam petang-petang jogging?
Besar ada.
Oh.
Orang Jepun main softball kan?
Softball sir Jepun. Baseball, softball.
Baseball, softball tu kan?
Yes. Baseball tu dia ni lah, terkenal lah. Football,
Tandas awam ni
lagi
bersih
tenis. Apa?
Tandas awam ni bersih tak?
Sawah?
Tandas awam dia bersih tak sir?
Oh, bersih. Tapi adalah setengah tempat tu yang macam busy sangat tu, hancing lah juga. Okay, Sat. Kita kena sekejap. Okay, kita kena start dulu. Dah 10 minit Alright. Habis dah. Sesi tu lah jawab. Nanti tanya lagi. Uh, so today we need to sekejap I share the tutorial. So I hope you guys faham yang I cakap pasal turning in tu. So basically I think I have replied everyone. So kalau you ada dua account and satu account you dah guna untuk submit, and then you already have the UTM account. So somehow you cannot merge. You tak boleh merge. So tak apa, you just stay there. Kalau katakan dia delete you punya non-UTM ni, then kita buat resubmission lah. Okay. So okay, let's so phase diagram, I think we have finished on question 1 and question 2. So today we will do the question 3 lah. So question 3 is a bit tricky. So okay, two metals A and B have melting points of 1200 centigrade and 900 centigrade respectively. A is soluble in B in solid state to a maximum of 8 weight% at 700 centigrade and 2 weight% at 0 centigrade. While B is soluble in A in solid state to a maximum of 15 weight% at 700 centigrade and 5 weight% at 0 centigrade. An isothermal reaction occurred at 700 centigrade containing 4 weight% of B. Okay, the question: based on the above information, construct a complete phase diagram of A, B alloy to scale on a graph paper and label all the phases, lines and points. Okay. So, since we don't do in Excel, so I'm going to use the Excel. Draw that. Okay. Nampak Excel? Excel nampak? Oh, siap. Saya tak share lagi tu. Ada nampak Excel?
Nampak.
Okay. So apa soalan yang kata? So we extract the information first. So dia kata, so what is being said here is two metal A and B. Okay, now we have A and B. Melting point, temperature of melting point of A equal to 1200. Okay, temperature melting point B equal to 900. Okay, so that is information number 1. A is soluble in B in solid state. Okay, A is soluble in B in solid state to a maximum of 8 weight% at 700. So A is soluble in B, maksudnya A in B lah. A in B meaning the host metal is B lah. Okay, A in B means A, we put some A inside B. Okay, so majority B lah, A in B. A is soluble. A ni dia dissolve, dia soluble dalam B. So A is yang sikit lah. A is soluble in B in solid state to a maximum of 8%. So A in B is 8%, 8% at 700 degree, and 2% 8% at 0 degree. Okay, and B is soluble in A. So this is the other way around lah. Okay, B in A, B in A. So host metal dia, majority dia adalah A lah. Sebab B dissolve dalam A. Okay. B in A is 15,700. Okay, 15 weight percent at 700. Lepas tu 5 at 0. 5 weight percent at 0. Right. So this is information number 2 lah, solubility. And then an isothermal reaction occurred at 700 centigrade containing 40 weight percent of B. So isothermal occurred at 740, yeah. 40 weight percent of B. Okay, so we have 3 component of information so far. The melting point, the solubility, this is the solubility, and number 3 the isothermal reaction. So based on this, we want to construct the phase diagram. So phase diagram, basically, first we need to plot that we need to prepare the axis first. Yeah. So horizontal we have composition, and vertical we have the temperature. Okay, let's do that. Okay, so A kita ada A dengan B A. Oops. A, so 10, 20, 30, 50. B. Okay, and then we plot for the Y block for the temperature. Okay. Then kita buat ni lah. Right. Okay, now we have the temperature as well as the composition. So composition, this one usually kalau dia buat A and B macam ni, so this 10, 20 is representing B. Okay, for most left hand side, we have 100% of A, 0% of B lah. So 0% of B. So going to the right is the composition, is the percentage of B. Is 10% of B, 20%, 30%, 80% of B, 90%, 100% B. No A. Okay, this is no A, pure. So we want to use the first information, melting point of A is 1200. So melting point of A is 1200. So we mark the point. Okay. So melting point of B is 900. So whatever going, above 900 is liquid form already. So below is solid form. Likewise this one. The upper side is liquid form, and then the lower side is the solid form. And okay, so now we have done the first. Padam lah ni. Or you want to see, sorry. Okay. Next, number 2, A in B. A in B. So majority is B. Okay, A is added into B. So majority is B, so it should be on the right hand side. Okay, right hand side. So 8% of A. 8% of A means 92% of B. Okay, 92% of B, 700. So, okay, 700, 92%. So, this is 90, so it's around here now, okay? And then 700 is here. Okay. Lepas tu, okay, 0%, 0 degree, 2%. So 2% of A, 98% of B lah. Okay, so we mark 98% of B at 0. Oh, mark. Okay, around that. So what we could conclude dari sini adalah when we say solubility limit, okay, if you go beyond that, kita akan jadi dua phase. Okay, as long as we go below the limit, the A will dissolve in B, so there will be no other phase, only B, because A is in B. But if we go beyond, it will be B plus A. Okay, it will be B plus A, definitely. So the microstructure will look like ada B and then ada A punya particle. Sebab dia dah tak boleh dissolve dah, dia terpaksa keluar. It has to form another form because it exceed the limit already, right? So if it go beyond, so this line, especially this point, if we go to the left more, it will be A plus B, not just B anymore, not just one phase, but two phases. Okay, so that's what it means. So vice, uh, you do the same for B. So B in A means the majority is B. Okay, the majority is B, and B in A majority is B. 15 weight percent at 700. 15 700. So 700 then 15 here. Okay, 15 here. And 0% 5. 5 here. Okay, now we already tackled this one, right? So likewise, the explanation is the same. Kalau if you go exceed beyond the limit, if you add more B, okay, B is for example 15% ke 5% at each point. So if you go beyond that, you put 20, it will be A, and B have to go out. Sebab dia dah lebih dia punya limit dah. Cannot solid, cannot dissolve anymore. Cannot it exceed the solubility limit. Okay. Uh, okay. That's information number 2. And then isothermal. Isothermal means the reaction occurs with the same or unchanged or constant temperature. So when you say that, okay, for alloy, I think you guys are already familiar with this. For pure meter, it look like this. The cooling curve is like this. Temperature and time. Okay. During the solidification, the temperature is constant. For alloy, the temperature is not constant. Okay. But for uh, isothermal reaction, it's not only the pure, but also if we have eutectic or eutectite. Eutectic or eutectite. So in this case, it will be like the pure, the cooling curve. Okay. So since we don't have, it's not mentioned any, any kind of like solid to solid changes. So we could say based on the information provided, we can say that this is a eutectic point. A eutectic point. So isothermal is equal to eutectic in this case. So eutectic is 700 degree and 40. So B40 700. So this is the eutectic point. So eutectic means from liquid directly to solid, right? So if you draw this one, uh, all the points we have now, with all the points we have now, with all the points we have now, okay, it looks like this. It will looks like this. And this is liquid. This is since it's A, so let's just put the phase as alpha. You can put any letter, okay, alpha. And since it is B, so let's put the Greek letter beta. And as I mentioned just now, here, if we go beyond the limit, so we will have alpha plus beta. We will have alpha plus beta. So this is how it looks like. So you can label more. This is liquid plus alpha. liquid plus beta. Okay. So there we have our phase diagram. Okay. So let's do next question. Okay, boleh tangkap dekat situ.
Boleh Ustaz?
Boleh.
Okay. So we go to the next. Name and write the isothermal reaction for the system. Okay. Let's ask Abu Bakar. Abu Bakar ada? Abu Bakar. Abu Bakar, I think last time I call you also tak ada. Amirul Hakim. Amirul Hakim ada? Tak ada juga. Fatin Shazana. Pun tak ada. Izzah Nur Laili ada? Izzah Nur Laili. Tak ada juga. Mutiah. Mutiah ada, Mutiah. Mana ada ni? Tan Nian Sien. Tan ada, Tan?
Yes, Doctor.
Okay, Tan. Finally, someone. Okay, name and write the isothermal reaction for the system. What is the isothermal reaction?
Eutectic reaction.
Okay, the reaction and
The equation
mhm.
L change to A and B.
Yes, very good. Okay, eutectic reaction L equal actually alpha plus beta lah in this case because we label as alpha plus beta. It's the same lah.
Alright.
Okay, and consider an alloy. Okay, thank you. So number 2, we want to consider an alloy containing 30 weight% of beta. Okay. So 30 weight% of beta, let's do that. Tarik dia ni is letak warna kat dia. Dia dash. Okay. So 30 weight%, at what temperature the solidification begin and complete? So sorry, this is the scale is not the same as in graph paper lah. Just want to show you guys what is the way to do lah. What's the how to do to complete the question, to answer the question. But in reality, we have to use the graph paper lah. So this Excel is not that accurate. So anyway, based on this our drawn phase diagram, so let's ask Zaidatul Hanim. Zaidatul Hanim. Ha. Tak dengar suara.
Yes.
Okay. Untuk for question C1. At what temperature does solidification begin and complete?
The solidification begin at 800 degree.
Okay, 800 degree. Lepas tu?
And it's complete at 700 degree.
700. Okay, 800 tu awak tengok kat mana?
Dekat bahagian yang
Atas ni.
ya.
Sini Okay, so actually I think the Excel is not so good. Because last time I draw it become 800, but this time we say 800 something. So I think we should do at graph paper lah, okay? Because so I could say that it might be this point lah, this point. Let's say 900 lah, senang sikit So if you use graph paper, it's more accurate lah. Okay, so this point and this point lah it signify the certification begin and complete. In just now I did for last class is 800. Okay. I don't know how come 900 kat sini. Okay, what are the composition of the phases at the temperature 750? So 750. Okay, if we want to know the composition, what should we do? Let's ask Shazwan.
Ya saya.
Apa kita nak buat kalau kita nak tahu composition phase tu?
Kita observe that point 750 degree tu dengan 300 300 pula. 30% of B tu lies at what point lah kot.
Okay. We are going the right direction. Contoh lah So
Around there.
basically you must do by graph paper lah. So I just
Yes.
do. So kat sini kan. Lepas tu we have this point. So what we do next?
Lepas tu observe dia lie dekat region apa, macam from that phase diagram liquid plus alpha metal lah.
Okay, liquid plus alpha metal. So kita tahu dia ada dua phase lah kat sini, betul tak?
Yes.
Okay, so kita tahu dia ada liquid and alpha. So dia tanya what are the composition of the phases at the temperature. Maksudnya dia nak tahu apakah composition liquid, apakah composition alpha. Macam mana?
Kita kena kira lah.
Kira
Apa kalau kena kira pakai level rule.
Tak sampai lagi kat situ.
Belum Okay.
Ini orang panggil tie line lah. This one
Okay.
kita panggil tie line. Tie line ni kita ni je, kita extend dia sampai dia touch liquid punya phase.
Yes.
Dan dia touch alpha punya phase. And then awak tengoklah composition dia kat bawah ni. Berapa persen. Contoh lah Contoh, I'm not sure this is apa. Contoh this point maybe around 39 ke, right? 39B and then the rest is A lah. Okay. So this one is maybe 18 kot. 18, 39. Actually last class I did the same but some value different lah because I didn't use the graph paper. So but the idea is the same lah. Okay, idea is from satu point ni, from this one point you expand until you touch the liquid phase or the alpha, and then you extend to the composition lah. Then you know lah. Okay, so for the liquid no button for resubmit. Ada sini tak? Zen. There. Kena reply ya. Wait first.
Okay.
Ha? Got deleted. Then resubmit. Okay, so liquid, for example, we look at here, maybe we can say 39B, and then the remaining is 61. Okay, okay, and then alpha it become berapa dia punya alpha dia berapa tadi? 18 tu kita kata. 18B, and the rest is 82% of A lah. Okay, so that is how we get the composition of the phase. Okay, first we identify what phase exists, and after that we check with the timeline what is the composition. Okay, question number 3. This one we use the lever rule. Okay, this one we use the lever rule. So lever rule very simple. We use the tie line, okay, but we measure the length, okay, partially. So we have two part. So let's use another color. So this is one part, this is another part. Okay, from eutectoid to this point, this at this temperature yang kita that we touch the liquid and the alpha phase. So we get this line, so we measure this line lah. So for example, this is 18 and this is 39. So the length, overall length would be 21 lah kan. Okay, so overall length will be, for example, we put this H and J. Okay, H plus J would be 21. H plus J would be 21. And H alone berapa? H alone from 30 30 we minus 18, so we get 12. J from 39 we minus 30, so we get 9 lah. Okay, so last class I get 24. So it depends on your graph paper lah. I hope if you use the same graph paper it won't have any variance lah. Okay, but the idea is the same lah, 12 over 21, and then this, okay, sorry. So if you want to know the L, you don't take the J here. The lever rule state that we need to take the H here, so we get the ratio. So H over H plus J is equal to the fraction of liquid, and alpha we have J over. Okay, so that is how you get. So ini you buat lah dia punya jawapan dia, kita tulis 12 over 21, so it should be pula betul. Should be Okay. Uh, 57%, and for this one it should be around 42 lah. Okay. So that is how we answer question number. And finally question number 4. Okay, boleh faham tak level rule tu? Okay kot kita just ambil dia punya length dia. Length dia, dan kita bahagilah. And finally, the explain with the aid of sketch the phase transformation of this alloy when it is slowly cooled from liquid phase to room temperature. So liquid phase to room temperature, we want to draw that. Liquid phase, we can assume it looks like this. It is still in liquid. So liquid. Then here, after it, the solidification begin, so this area, it should be some solidified alpha surrounded by the liquid phase, remaining liquid phase. Okay. And this is the alpha plus liquid plus alpha, and when we go beyond this, so the remaining liquid, it will change into what we call as alpha plus beta. So you already have in the beginning, you already have this pro-eutectic means before eutectic point, the solidified eutectic alpha, we have the pro-eutectic alpha. Okay, and then after you exceed the eutectic point, you will have beta. Okay, beta, let's say beta is this color. Okay, beta. It may be in lamella, or it may be in, round shape. It is not fixed lah. It's based on the material, based on the diffusivity and all those complicated things lah. You need to learn more on that. You need to do simulation, but the idea is you have a mixture of beta and the eutectic alpha. The eutectic alpha. Just now is the pro-eutectic. Now we have the eutectic alpha. Alpha that formed during eutectic or below eutectic point. So we want to divide that. Okay. So this is how it looks like. You can draw much better lah, okay? So this is all about the phase diagram. I hope you could. There are two things you need to be able to use. One is the tie line for like the question number 2, and the other is the level rule. That's the most important aspect that you need to know when you're dealing with phase diagram. Okay, okay tak? Okay. All right. Okay, so I guess if you have any question, you can always reach me. And see you guys next week. Bye bye.
Thank you, sir.
Okay.
Bye,
Thank you,
Doctor.
Doctor.
Thank you.
Okay.
Thank you, sir.
Bye.